Okay, so we did a little bit of a review of inequalities right before we took our virtual days. So you get the greater than sign, less than, greater than equal to, less than or equal to. Inequality means they're not equal. We're looking at things that are not equal to each other. Then we did a review, and let me just give you a problem as an example. If we had x plus 5 must be greater than 12. All right, and if you remember that day, we went on a whole big long story about what can I do to both sides of an inequality that keeps it balanced. Because we want to treat this just like an equation. We want to get x by itself so we can solve it. And if you remember, we learned there's one rule when you're solving an inequality that makes them different than equations. If you multiply or divide by a negative number, you must change the direction of the inequality. So for this problem, if I had to solve this inequality, which means get the variable by itself, we could do what? X is being added by 5, so we would subtract 5 from both sides. 5 minus 5 is 0, so that leaves me with x, and 12 minus 5 is 7. The inequality will stay the same direction, right, because I just subtracted. Okay, so this is solving an inequality. How many variables were in this inequality? 1. There was just the variable x. So once I solved and got the variable by itself, if you remember, I showed you we had to graph it to show the numbers that were true. So like this says x can be anything bigger than 7. That means x could be 8, 9, 10, 11. It could be 7.5. It could be 7.1. Right? Anything bigger than 7. And so the way we show that on a graph is, because it has one variable, we just need one axis. So I'm going to number 0, 1, 2, 3, 4, 5, 6, 7. Let me make my graph a little bigger. 8, 9, 10. So this says x can be anything bigger than 7. What did we do? We went to that point of interest, 7, and we would circle it. And then we want to shade in anything that could be an answer. So we said, what were the possible answers? 7.1, 7.2, 8, 9, 10. It's numbers going in this direction are our answers. So we would shade everything to the right of 7. And then we would shade an arrow going, and it's hard for me to do on this iPad. We would shade an arrow going in that direction. That's what this is. This is my arrow. About not being able to list all the possibilities. We've done something like that already this year, where I showed you what's an example of a problem we've been working that has a lot of different answers that you can't list them all. There's a couple that come to my mind. Yeah. So we had infinitely many solutions when we graphed two lines that were on top of each other. But also, the whole reason we graph lines is, notice this equation. This equation has what? It has two variables instead of one. So what makes that different? Well, if I get one variable by itself, the answer is still going to have another variable in it. Right? So what are some things that make this equation true? X plus y equals 10. 5 and 5. So how could I write that? I could write it as an ordered pair. Right? If x is 5 and y is 5, that's an answer. Is that the only answer? What else is an answer? 8 and 2. I heard somebody else. 6 and 4. 1 and 9 and 9 and 1. Okay, 3 and 7. 2 and 8. 4 and 6. 10 and 0. 7 and 3.
9 and 1.
We've got 9 and 1 there already. What about 9.5 and 0.5?
Yeah, that's what I was thinking.
What about negative 20 and 30? How many different answers can I write for this equation? There's an infinite number of answers. So how can I show you all the answers when I have an equation with two variables?
A graph.
A graph. That's what we did. If I had x plus y equals 10, click the wrong button. Give me just a second. Well, that's not working anymore. Sorry. So if I had x plus y equals 10, I could show you that answer by graphing it. So how could we graph the line x plus y equals 10?
We find different variables in the equation.
We could. But there's one way that we've learned how to graph lines. Really. If we put this line in slope-intercept form, what needs to happen to be in slope-intercept form?
Y needs to be on its own.
Y needs to be by itself. So I could subtract x from both sides.
Negative.
So y equals 10 minus x.
Then you can switch the placement of the variable.
Rearrange it. Put the x first. So it's negative x and a positive 10. Remember, the sign in front of the number goes with that number. So now if I had to graph this line, okay, how do I start by graphing this?
Go to plus 10.
Go to the y-intercept, which is 10. So on my y-axis, I'm going to count up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be right there. 1, 2, 3, 4, 5, 7, 8, 9. I plot my point. And then I would use the slope to find more points on this line. So that would be, the slope is what here?
Negative 1 over 1.
Negative 1 over 1, which means I can put the negative on top or bottom. So I normally put it on top. That means I can go down 1, right 1, down 1, right 1. What does this line represent? The solutions. Do you remember all those ordered pairs that we wrote down that I've got hidden? Here's a few of them. Right? We said 10, 0 should have been an answer. So let's see if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. That point is on this line. All right, what's another point that should have been on the line? 9, 1. Let's go with like 5 and 5. Right? That's where we started. So if I go right 5, up 5, that point's on the line. 0, 10 is on the line. All those points that we named are on this line. The line is a visual representation of all the answers. I can't list them all, but I can show you them all on this graph. Okay, that's why we graph lines. Now what we're going to do is we're going to take inequalities and lines and put them together. Okay, so here's an example. what is the solution of the inequality y is less than or equal to x minus 1? Notice how this inequality has two variables, an x and a y. So it's like a line. But it has an inequality symbol, so we've got to shade the things that are our answer, like we do with an inequality.
Wait, so would that already mean it's in slope-intercept form because it's equal to?
Does that look like slope-intercept form? The y's by itself. Instead of an equal sign, it is an inequality, but this is still mx plus b. So I still can get it in slope-intercept form. It's just not going to say equal to. It's the only problem. But all my rules for inequalities are still valid. So let's go ahead and graph that because we know what y equals x minus 1 looks like. Now I am going to advise you to draw smaller x and y axis on that graph paper, because I don't have just an infinite amount of graph paper to give out. So don't use the whole big paper as one graph, right? Use smaller graphs within there. Okay, so we said this is in slope-intercept form, so what is my y-intercept? It'd be -1. Remember, the sign in front of the number goes with it. So this crosses the y-axis at -1. Is everybody ready for me to keep going, or do I need to give you another minute? Good talk. Good talk. Thanks so much for all your input. Okay. So the y-intercept, where it crosses the y-axis, is -1. So I put that point on my graph. Then I use the slope. What is the slope of this line? 1/1. Which means from here I go up 1 and right 1. All right, now I want you to put the points down, but I don't want you to draw the line yet. So for me, I put as many points as possible because I can't draw a straight line to save my life. So we know, let me give you time, sorry. I get carried away. I'm not good at waiting. No patience. We know if we were going to draw a line here, if this was an equation, what would we do with these points? We would just connect them. Because we would say all the points on this line are a solution. But now think about what we had to do with an inequality. If you'll remember, with inequalities, with one variable. Remember we went to 7? We had to shade right or left. But the first thing we had to do is decide, should the 7 be included in my answer? How did I know if the 7 was included or not? Well, if I said x was greater than 7, that's an open circle shaded to the right. But if I said x can be greater than or equal to 7, so I would put a closed circle at 7, and I would shade to the right. We have to account for this open or closed circle when I have two variables in an inequality. So here, because this is less than or equal to, would it be an open circle or a closed circle?
Yeah, closed circle.
Closed circle. Closed circle means it's included in my answer. Here what that means is the line is part of my answer. So here's how we show the difference with an inequality. If it is less than or greater than, that means the line is not included. Line isn't part of the answer. We can go all the way up to the line, but the line isn't part of the answer. Kind of like here with 7. We can go all the way up to 7, but 7 isn't greater than 7. It's not part of the answer. The way we show that graphically is we're going to use a dashed line. If the line isn't part of our answer, we don't connect it all the way. We're going to do a dashed line. Now, if we have less than, equal to, or greater than or equal to, then that means the line is part of the answer. That would be like filling in the circle. Right? Is 7 greater than or equal to 7? Yes. So fill it in. So when the line is part of our answer, we're going to use a solid line. Just like what you're used to drawing a line. If it's got an equal to sign underneath it. So my question is, the reason I told you to leave these dots, we have to decide, is the line part of the answer or not? In this case, the line is part of our answer because it has an equal to sign. It's included. So all my dots that I have will be connected with a solid line. Okay, so everybody understands why this is a solid line. Because it has the equal to sign. So that is me deciding open circle or closed circle. Now what's the second part of solving an inequality? We have to shade in the correct direction. We have to either shade right or left. With a line that's an inequality, we either have to shade above the line or below the line.
So like it makes it like a parallel line kind of.
It's not going to be parallel. You're going to shade everything above it or everything below it. Just like out here, we would fill in everything to the right or left. Not necessarily the quadrants. The line. The line is the divider. Like here with an inequality, the circle is where we divide it.
Yeah.
With a line, the line is the division. So this says what? This says we want to shade all y's that are less than or equal to x minus 1. So I want the y's to be less than the line. That's the way I think about it. The y's are less than this line. So here are the y values on the line. So the y's less than that would be underneath it. Right? Because like right here. And if you don't know, here's the way you can tell. Because people struggle with this all the time. What you can do is pick any point on the graph. So what's a point? Okay? Make sure that point is not on the line. So is 2, 2 on the line? It's not. It has to be not on the line. So we can pick 2, 2. If I plug in 2, 2, does it make the inequality true or false? So y becomes 2, must be less than or equal to, the x is 2 minus 1. So is 2 less than or equal to 1? Is this a true statement or a false statement? It's false. So is 2, 2 an answer? No. So its part of the graph shouldn't be shaded because we shade the answer. So the answer here would be the other half of the graph. It would be everything beneath it. Oh. And just to prove the point, let's pick a point that's underneath. So let me pick this point. That way I still got a positive one. That's the point 1, 2, 3, 4, 1. Okay, if I pick the point 4, 1, that would tell me 1 is less than or equal to 4 minus 1. So is 1 less than or equal to 3? So you see, this point is included in the shading. It's part of the answer because it makes the inequality true. And that would be your solution to this inequality. You're combining those two parts that we worked on. We did the inequality just barely because this was supposed to be a review. You were supposed to have already done this. And y'all told me you had seen it. Right? The open circle, closed circle, right or left. Yeah. And then I taught you how to graph a line. So now we're putting those two skills together to graph inequalities. Okay, so we're going to graph this one. Y must be less than negative 3x plus 5. So we're going to start by making our x and y axis. this is an inequality, and it has two variables. It has an x and a y. So I know I have to graph a line to show the solution to the inequality. Is this in slope-intercept form? Y equals mx plus b. Yes, it's in slope-intercept form. So I can graph it. If I'm going to graph it, I start with the y-intercept. So this line should cross the y-axis at 5. So I'm going to count up to 5. 1, 2, 3, 4, and 5. I'm going to plot my point at 5. Question so far. Next, I'm going to use the slope to find other points on this line. So the slope here is -3. We can always take a whole number slope and write it over 1, which means I'm going to rise -3. So I'm going to go down 3. 1, 2, 3, and write 1. Again, I'm going to do that a couple more times because I'm not good at drawing a straight line. Down 3, write 1. Down 3, write 1. Down 3, write 1. Could also go up 3 and left 1. Could put me somewhere right in here. So those are the dots that make up my line. Now I need to decide, should my line be solid or dotted?
Dotted.
Because there is no equal to sign. Remember, the equal to sign means include the line in my answer. But because there is no equal to sign, it's not part of our answer. So the way we show that, this is like the open circle. We show that by writing a dotted line. And I am never any good at doing this on the iPad. You know like the lines on a road?
Yeah.
That's what it should look like. A what? Yeah, I had a pen at one time, but to use the pen, I had to wear a glove because
It's
it's
like
heat.
Michael Jackson.
Yeah. My glove only went over my pinky and my thumb.
Yeah.
It was weird. It was a weird. And
And
it's supposed to make it where it couldn't sense my hand on the iPad,
Yeah.
and I didn't like it. And it didn't always work. So sometimes it would catch my hand all of a sudden and just put a big like that, just random. And I thought, I don't want that. It still got through the
Do we
glove.
still include like an arrow on it too?
Yes.
At the end?
Yep, good call, because I was being
Goes on
lazy.
forever?
This line does continue in both directions forever, so it should have an arrow. And now, this is one that I could see being a little trickier. I need the y's to be less than -3x plus 5. So for me, here's the line, and I know if y must be less than the line, then I'm looking for the y's that are here, because this is beneath that y-intercept. Okay, but if you don't know, if you're a little confused, pick a point. You can pick any point and see if it should be in your answer or not. So let me say it again. You can pick any point not on this blue dotted line. So I would pick 0, 0, because it's not on the dotted line. And let's see if 0, 0 works, then I need to shade this side of the line. If 0, 0 doesn't work, then I need to shade this side of the line. So let's plug in 0, 0. That would be 0 is less than -3 times 0 plus 5. -3 times 0 is 0. And 0 plus 5 is 5. Is 0 less than 5?
Yes.
Yes. So that means the point 0, 0 should be
Everything's
an answer. So I'm going to shade everything on this side of my line. You can think of it as to the left. I always think about it as beneath the line, because I know this point's on the line, and I think of the y's beneath it. And that also helps me with the less than. which means we would be shading over here.